All right, let's put this formula to use. So I'm given angle A is 39 degrees, angle B is 75 degrees, and my side length A is 3. So just to get a visual of what's going on, I'm going to go ahead and just give myself a random triangle. It's not going to be accurate. I'm going to label it however I see fit. Well, obviously using the names that they gave us. And then I'm going to go ahead and put in the values just to get an idea. I know that 75 degrees doesn't, well, it's not that bad. And then we know across from big B is little b, and across from big C is little c. Now this is not a right triangle, so I cannot use Pythagorean theorem. But I can figure out this angle, which is C, because the triangle adds up to 180. So 180, take away the 39 plus the 75. Please get in the habit of using degree symbols. We mentioned this in class because it's talking about units. So if I do that, I end up getting 66 degrees. So remember when it says solve for the triangle, I have to solve for all the missing parts. So it looks like I have 2 more parts to solve for. So this guy is 66 degrees. And check and add those all up. Make sure that they're in fact 180 degrees. All right, so I'm going to do now sine of 39 degrees over 3 equals, I'm going to end up doing, well, it doesn't matter, but I'll do b first, sine of 75 degrees over little b. And since we have 2 proportions equal to each other, we can cross multiply to solve. So I end up getting b times sine of 39 degrees equals 3 times sine of 75 degrees. I'm going to go ahead and divide by sine of 39 degrees. And I'm going to beg you to not do any rounding until the very, very end. So I'm going to go ahead and pull up Desmos because this is the calculator we'll be using. So I'll give you Chromebooks to use when you take your exam, so you do have Desmos while you test. So, all right, it looks like I might have to make this a little bit bigger. But the key thing is to make sure that you're in degrees. So if I go between, that says rad now, and then it says degrees. Rad is for radian, we'll talk about later in the term, but we want to make sure it says DEG. And then I'm going to do 3 times sine of 75. I'm going to close that parenthesis. I'm going to divide it. So maybe this won't affect my answer, but I want to get us in the habit of making sure we're paying attention to these kinds of things. That 3 is in the numerator, so I'm going to put the whole thing in parentheses. And then I'll divide, because then it puts the whole thing in the numerator. It wouldn't have affected our answer, but I want to get you in good habits now, so when it does, we aren't out of luck. So it looks like we get about 4 point, we typically went around to the second decimal place, so that would be 4.60. All right, so now, and notice how I put approximately, the approximately symbol, that's important. So now I'm going to go ahead and try to get rid of this thing. And no. Okay, sorry, you're going to bear with me. All right, so now I have to solve for C. And I like to always use the full ratio that was given to me. Just in case I butchered that 66, well, that 66 I'm going to have to use. But if this piece, this 4.60 has been rounded, so I definitely don't want to use that in my ratio because my final answer will be off. So now this will be sine of 66 degrees over a little c. And if you cross multiply again, I guess I actually can go ahead and put exactly equals since I didn't do any rounding at that moment. And I'm going to divide by sine of 39. So going back to my good old Desmos, I'm going to go ahead and get rid of this since we already figured that out. And it looks like it's covering it, so let's see if I can figure that out. All right, so now I'm going to do 3, oops, let me follow my rules and put it all in the numerator. 3 times sine of 66, close, divided by sine of 39. Looks like we get about 4.35. All right. So hopefully that makes sense. And I'm going to go ahead and go to the next example. So I encourage you actually to try this on your own and then come back, okay, and just check your answers. But I'll keep going with it. So A is 35 degrees, B is 17 degrees, and C is 3. For some reason I was like, are those the same values? Here we go. A, B, C. A is 35 degrees, B is 17 degrees, and C is 3. A, little b. Okay, so once again, it's the same exact process. It's just like the other one. We can go ahead and solve for that missing angle because the triangle adds up to 180. All right, so when I do that, I end up getting 128 degrees. All right, so now I have to solve for A or B, whichever one you want to do. And I didn't mean to do that, excuse me. Zoom out again. All right, so now it's going to be, so now my full ratio has to use what I just found. So sine of 128 degrees over 3 is approximately, and it's whatever one you want to solve for, so I'll do A. So clearly my triangle is not drawn accurately if that's 128 degrees, but it was just to give me a visual. And cross multiply. And just to save a little time, but you can be doing this on your own hopefully, I'm going to end up getting 3 times sine of 35 degrees divided by sine of 128 degrees. And using Desmos, I end up getting 2.18. All right, now I have to solve for B. Again, I'm going to stick to the answers I did not have to round, so there's not a rounding error at the very end. And so that is sine of 128 degrees over 3 equals sine of 17 degrees over B. We cross multiply. So we end up getting 3 times sine of 17 degrees over sine of 128 degrees. And using good old Desmos, we get about 1.11. All right, I'll see you in a second for the ambiguous case.